This 3-mark congruence question cooked most GCSE students. It's fair to say Edexcel can be savages sometimes. But let's take a look at the question, see how to address it. Stay calm, stay collected. Life's good, mate. We'll figure it out. So we have ABCD is a parallelogram. All right? A, B, C, D. Parallelogram. All right? ABP, ABP, and QDC are straight lines. Angle ADP, ADP, and CBQ, CBQ are 90 degrees. Prove that triangle ADP, ADP, so this right angle triangle here, 1, 2, 3, yeah, this one, is congruent to CBQ. 1, 2, 3. Obviously, I can do fancy colors for you guys, but in an exam, you're not going to have fancy colors. So let's do this just from eye. Now, we have this triangle. This one, we're trying to prove that they're the same. So congruent means the same. Now, there's 4 ways we can prove that triangles are exactly the same. The first way is they have the same sides. So if you have 2 triangles which have the exact same sides, they have to be exactly the same. The second one is SAS. Now the way I remember this, all you Liverpool fans, Suarez and Sturridge. You guys are Utes, you probably don't even know who they are. But Suarez and Sturridge is the way I remember SAS. I'm not even a Liverpool fan, but it helps me remember it. Now, this order only. We can't switch things around, okay? The third one is ASA, okay? You have 2 triangles which have an angle, side, and angle being the same. Now, this could be in any order. Okay, so you could have AAS, you could have SAA. I mean, these 2 are the same, it just depends how you look at it, okay? Then the fourth one is RHS. Right-hand side is how I remember that one. So that one is a right angle, hypotenuse, and a side. So this is looking at 2 right-angled triangles. So if you have 2 right-angled triangles, doesn't matter. Wait, what's that? Okay, like that maybe. As long as the hypotenuse is the same for both, they both have a right angle, and then they have a side which is the same, then they have to be the exact same triangle. This one, you're saying, look, if you have 2 triangles where you have the angles being the same, I don't know, like this, and they just need to have one side being equal in that order. So if I have ASA, the in-between angle would have to be like, or the in-between length would have to be S, then the same. So by the angles in a triangle, the third angle has to be the same, and then to have the same length means that they have to be the exact same triangle. SAS is by the cosine rule. Yeah, if you have 2 triangles which have 2 sides, S1, S2, even if I have it the other way around, S2, S1, if they're the same and they have the angle in between them the same by the cosine rule, then the third side has to be the same. And that's why these are the only ones that are allowed. The one that's not allowed, guys, is 2 S's. Yeah, 2 S's. If you have 2 S's next to each other, not allowed. SAS, the S's are not next to each other. If the S's are next to each other, not allowed by the ambiguous case for sine. Okay? So, by these, which one are we going to use? I'm going to get rid of this saw, because we don't need it. Which one are we going to use? Well, I recommend in the exam, you just write them down, and you just tick off as you go. Now, one thing's for sure is SSS, I'm probably not going to use that because they're giving me angles. Okay, so it's one of the ones with the angles. Now, I'm going to say that they both have 90 degrees. So, ADP equals CBQ equals 90 degrees, and this is given. And this is an angle then. Yes, that's my A. So, I'm already not thinking about triple S. Okay, I have A, could be one of these, A. Now, I could say it's a right angle as well, maybe. So we could say A/R, raw. Okay, well, is there another angle that's the same? Then we could go down this route. Maybe a side would be better. How could we use a side? Well, they did tell us that we have a parallelogram, right? So parallelogram meaning this side is equal to this one, and this side here, if I just remove these parallel signs for a second, 1, 2, 3, this side would be equal to this one. Okay, remember they are parallel. Are any of those part of the triangle? So we had this, yes, BC, BC, and this triangle, AD, so BC equals AD. So BC equals AD, and this is a side, okay? So this one we're saying op sides of parallelogram are equal. I would always write an explanation. Is that a hypotenuse though? Right angle, so here's my triangle, right angle, the hypotenuse will be here. No, so that's a side. So it can't be H, that's going to be a side, if I'm going to use that. A side, and one of these sides. So either I'm going to go about the route of finding another side, finding another angle, or finding the hypotenuse. Now in terms of the hypotenuse, look at this right angle. Opposite would be QC. That length. Do you think you guys are going to be able to explain that? That length is the same as this one? No. Because they haven't said APCQ is a parallelogram. If they said it was, then yes, you could say that. I'm not going to be able to prove that. Another side. Okay, so we have the angle side. So if I'm going to use SAS, side, angle, side. I somehow need to prove that this side is the same as this other side on the other triangle. How are you going to do that? QB and DP. Are you going to be able to say that they're the same? I don't think so. How? Did they tell you this is a parallelogram? They didn't. So you can't use it. Sorry, Suarez and Sturridge. It looks like you're not going to work. I'm going to have to prove another angle. All right, so AS, ASA, or AAS. Yeah? So it's just to locate the angles that I'm talking about. So we have this one and this one. So I have this A and I have this side. So either I do AAS or I do ASA. So we got to figure out, you know, these two angles here, can we say they are the same on the other side? Is it possible? Well, I really want to focus my attention on the fact that they did tell us that there is a parallelogram. So in a parallelogram, the opposite lengths are the same and the opposite angles, okay? So we do have this parallelogram, and if I have this angle which is in the parallelogram, that must mean that its opposite is the same. And that is part of this triangle, okay? So that's my final angle, ASA. So we're going to say DAB, DAB, equals BCD. So here is opposite angles in parallelogram are equal. Therefore, congruent by ASA. Okay, so guys, you can't say AAS because that would not be correct. Okay, so just because you worked out two angles in an S doesn't mean, so I could have written this up here and it looks like AAS, but actually you use ASA. All right, so guys, you have to be very careful with these kind of questions. So yeah, that is it, guys. I think part B, there was a part B to this. It was like prove that I think AQ and PC were the same. Well, that's simple because we have these two triangles are congruent. It means AP equals QC. Yeah, so these two opposite lengths are the same. So then we have this parallelogram situation, which then you can say that these two, I think it was something like that. These two are the same. Okay, so guys, if you learned something today, make sure you like this video, subscribe for more maths content, and did I say subscribe? Yeah, might as well subscribe. And if you're interested in my GCSE courses, feel free to check out the description, more information there and that. And head to my Lung Gang Reddit page if you want to submit your own maths questions and get feedback from the community. I'll see you guys in the next video. Nice.